welcome to our Vodcast for Math 130. Our topic of choice was Pythagoras' theorem. Pythagoras of Samos was a mathematician and a scientist who was born in the city of Samos in Greece in the year 570 BC. He passed away at 495 BC and he was well known for his Pythagorean theorem. So where did it all begin? There are many arguments stating the fact that knowledge alike the Pythagorean theorem was discovered long before the theory was actually proven. Ancient Indian and even Babylonian mathematicians were thought to have used this theory way before Pythagoras was even born. However, the theory was made official at around 530 BC and was named after himself, Pythagoras, the Greek mathematician. Many myths surround Pythagoras and his life. Some of the many debates existing relates to whether Apollo was his father or not, or that he had a golden tie, and also that he could be in numerous places at once. So what can the theorem be applied to? Throughout life we may come across situations where we have to find a logical solution. The Pythagoras theorem is where in many instances can determine what we should do. These instances can be like the pyramids, length of trees, length of ladders, or even when it comes to architecture and building to that level of complexity.
So now we'll look at the concept of Pythagoras' theorem. The Pythagoras theorem was discovered when Pythagoras used squares to create a right-angled triangle, as you can see on the right. He began to notice that there was always one square larger than the other two. He then began to question people around him that if the squares were made of solid gold, would they take the two smaller squares or would they take the larger square? Predictably, they chose the larger square. However, Pythagoras knew that both the two smaller squares against the largest were always the same size. And as you can see in the examples case, the largest square is 25 units, and the two smallest together are 25 units also. So, in summary, that's how I discovered that the sum of the two smaller squares equal the largest, and that's hence the formula that we have for Pythagoras is a squared plus b squared equals c squared.
Many people, such as painters who need to reach high places, need the use of Pythagoras to determine what size ladder they will need. For instance, a painter may know a length from his standing point to the building. We'll call it distance A, and the height of the building he needs to paint, distance B. Therefore, the ladder length will be distance C. We use the Pythagoras formula of a squared plus b squared equals c squared. C is always the longest side on the right angle triangle, and also known as the hypotenuse. A and B can be on either sides of the C. Just remember, the Pythagorean theorem can only be applied to a right-angled triangle. In this example, the formula is a squared plus b squared equals c squared. We input the information which leads us to get 5 squared plus 12 squared equals c squared, giving us 25 plus 144 equals c squared. Therefore, c squared equals 169. C is the square root of 169, giving us the overall answer of c equals 13. We input this information which gives us 9 squared plus b squared equals 15 squared. This gives us 81 plus b squared equals 225. We take 81 from both sides, giving us b squared equals 144. We square root 144 to give us the final answer of b equals 12.
Pythagorean theorem is useful in working out the distance between 2 points, which obviously assists us greatly in navigation. If we know the coordinates of 2 particular places, we can use them to determine the distance between each point. I have demonstrated an example using the Cartesian plane, which can be translated to coordinates on a map. Point A is located at 5, 4 and point B at 2, 1. By working out the lengths of each side and using the distance formula, it gives us the distance between the points, as can be seen below. As long as you know the lengths of 2 sides of a triangle and use the formulas correctly, Pythagoras' theorem is extremely helpful, although there are a few limitations. It becomes an issue if you don't know 2 sides of a right-angled triangle, or at least an angle on a side. And the theorem only works on right-angled triangles, therefore limits how much we can use it with triangles.